Hi there, welcome to the Birds of the World Discovery webinars. I'm so glad that you're all here. We've got so many people, a really diverse group. 800 of you have signed up for this webinar, so thank you for being interested in using these tools, and I hope that you learn a lot today. So as you know, for the next 3 weeks, we are hosting an online science webinar that will show us how to analyze eBird status and trends data. And these data can be used to develop high-resolution data visualizations and tools that describe where bird populations occur and how they change through time. So a few logistics before we get started. The bulk of the workshop is scheduled for a solid hour, and we're going to hold at least 30 minutes for questions and answers at the end. It could run a little longer, up to 2 hours. Thankfully, our team has decided to stick with us and just really help do what they can to answer all your questions. But please realize, with so many people being present today, we might not be able to get to every question. So if you have any questions, please drop them in the Q&A, which is at the bottom of your screen. We'd like you to reserve the chat for just general discussion, but we will be monitoring the Q&A most for questions that you have. And let's see, closed captioning is available. So again, at the bottom of your screen, if you'll just do the CC button, you can do get a translation for your language, I believe there. The webinar will be recorded and will be available on the Cornell Lab of Ornithology YouTube website, and it's under the Birds of the World playlist. So we'll drop a link in the chat to that at the couple times through the series. And if you have any feedback for us on how this goes, this is a bit of an experiment, having hundreds of people doing an online science workshop. So we want to provide as much value to the audience as we can, but we realize that just due to it being online and also because there's so many people in the audience, there might be some things that we can improve. So definitely send us a note afterwards, letting us know what worked or what didn't. Later on, we're going to drop a poll, right? I believe. So one of our lovely panelists will be dropping a poll. So keep an eye out for that. We'd really love to know a little bit how experienced you are with this and ask your ideas about a forum. So if our speakers, our eBird Status and Trends team would like to turn on their volume and their videos, that would be great. Awesome. So welcome. We've got Matt Strymus-Mackey, Tom Auer, and Andrew Stillman today. Thank you all for coming and putting on this webinar. You're providing a lot of value to us and to the audience, so thank you so much. I thought we could just start with you introducing yourselves very quickly, and then if one of you would then kind of describe what the audience should expect from this first webinar, and then maybe a little bit about what to expect overall for the series. And after that, you can get started.
I'll start with introductions. My name is Tom Auer. I'm a lead geospatial data scientist here at the Center for Avian Population Studies at the Cornell Lab of Ornithology. I help lead the production of our data products.
I can jump in next. My name is Andrew Stillman. I'm over here in the same room as Tom. I'm a quantitative applied ecologist at the Cornell Lab of Ornithology, and my job is to do research and development to put status and trends data sets from eBird to use for bird conservation needs. And so I work very closely with a number of different state agencies, joint ventures, and the U.S. Forest Service. And one line of inference that I'm especially excited about right now is generating inference on habitat use and habitat associations using eBird data. Over to you, Matt.
Hey, and I'm Matt Strymus-Mackey. I'm a data scientist on Tom's status and trends team. I do a bunch of different stuff, but maybe most relevant for this workshop is that I maintain the R package that you can use to access the status and trends data. I'm going to try sharing.
While Matt is sharing his screen, I wanted to let everyone know that Tom and I will be the people that are kind of manning the Q&A. So if you see answers coming in, it's from Tom and I that will be answering those questions, and then Matt will be leading a number of our sessions and tutorials today.
Thanks, Andrew. Okay, so let's start with a little sort of high level overview of the content for today. This was advertised as an R workshop, and we are going to get to the R content a little bit later, but I want to start with a couple of other topics first that aren't specific to R. So I'm gonna do kind of like a walkthrough of the Status and Trends website, just to show you some of the different products that are available through the website, and then also maybe some features of the website that aren't familiar to some people. And then Tom's going to talk about how you can download data directly through the website, and then how you can open that spatial data in a GIS platform. So for a lot of people, you may actually be able to completely avoid using R entirely and just do what you need to do, like make a map, for example, in something like QGIS or ArcGIS. And then we'll jump into the bulk of the content, which will be about an introduction to this package eBird ST, which is the package that we've developed to provide access to the Status and Trends data. And we'll talk about downloading the data, loading it into R, and then how you can do a couple of different fairly simple applications, but applications that a lot of people want to do. And then we'll save time for questions at the end. And like Laura said, we can hang around past the 90-minute mark to continue answering questions if there are more questions. So this is part of a three-part series of webinars. Today will be very much an introduction, and then next week at the same time, we'll have a webinar focused on status applications. So when I say status here, I mean the stuff that's not trends. So all the stuff related to the estimates of relative abundance. And then the following week, we'll talk about trends applications. Both of these will be very much R-based webinars. So today, especially the early part, will be sort of accessible to people who don't have a ton of R experience. These will require more R experience, and also the idea with them is to have attendees from today submit questions or potential applications that they're interested in, and then I can cover those, or we can cover those in these subsequent workshops. One thing I want to make really clear right from the beginning is that we're not going to talk about raw eBird data. And when I say raw eBird data, I mean like the individual observations and checklist data, which is also accessible to download through the eBird website, but that's not the topic of this series of webinars. But I will just offer a few resources for people that are interested in that stuff, and I'm going to ask Andrew to post a few links in the chat. First, just on the eBird website, there's a page where you can get information about how you download the data, and you can request data to download. Second, we have developed an R package called awk that's specifically designed to work with this raw eBird data. So you can look at there's some tutorials and stuff on the website for that package. And third, if you're specifically interested in species distribution modeling using the raw eBird data, we developed this resource called Best Practices for Using eBird Data, which has some pretty detailed tutorials about how to model distribution and abundance using eBird data in R. And finally, I'm just going to pass it over to Tom to talk about some of the coming changes to the release schedule for Status and Trends.
Thanks, Matt. Yeah, I just wanted to give an update based on where we are as of today, October 2024. For the status data products, we have a delayed update coming of 2,500 to 3,000 species sometime in early 2025. We experienced some issues with the supercomputer that we use, but running is going smoothly now. If you've been a user of the data products, you may have been frustrated that some species are from 2 different version years. We're going to replace everything with 1 version year coming up, so that will no longer be a problem. However, there won't be an additional release later in the fall of 2025. And we're likely to start up the regular releases again in the fall of 2026. We've been discussing a new cadence of doing it every other year that isn't fully confirmed at this point, but is likely. And this gives us an opportunity to make more substantial improvements between versions and gives us a little bit more breathing room. For trends, there will not be updates in either 2024 or 2025, but we are going to maintain a regular release in the future. That schedule is to be determined, but it will happen. Trends are not going away. And the purpose of this is to focus on research and development to improve the estimates themselves, to improve the spatial coverage of what we can do, and to add features that people have been asking for. So that's the plan for now. If you have questions about that, please go ahead and put them in the Q&A and I will handle those. Back to you, Matt.
Okay. Wow. So I see there's like 250 people here. That's really impressive. So before I get started, can everyone, from maybe Tom and Andrew, you can hear me okay? Everything's good on that end? Okay, great. Okay. I'm just going to share my browser. Okay, so you should be seeing the eBird homepage. Is that correct? Okay, so I'm going to do, as I said, a sort of a walkthrough of the eBird Status and Trends website. I think everyone here has already been there, but just in case you haven't, you go to ebird.org, the eBird homepage, click on the Science tab. And then if you scroll down, you'll see there's this eBird Status and Trends. So this is like the landing page where you can get everything related to eBird Status and Trends. If you click on the Explore All Status and Trends Species, this green button, this will give you a complete list of all the species for which we have visualizations. So it's just under 2,500 species at the moment, 2,421. And in this view, it's organized taxonomically, and you get little images of the different birds. A lot of people will just be interested in the species that occur in a region of interest to them. And if you want, you can click on this filter button. And under region, you can put the region that's of interest to you. So for example, let's put in New York, because that's where Cornell is based. And now we have the 522 species that we have data for that occur in New York, at least according to eBird. These are species that have had an eBird observation in New York State. So you can scroll down and you can see that it's organized taxonomically. And as an example, let's select chimney swift here. And when you pick a species, you're dropped into this seasonal relative abundance map. And this map is showing estimates at 3-kilometer resolution of relative abundance for each of the standard seasons throughout the year. So in red, you have the breeding season. In yellow, you have the migratory seasons. And then in blue, you have the non-breeding season. And the quantity depicted here is, we refer to it as relative abundance. The definition of that is the number of birds an expert observer would expect to see on a 2-kilometer, 1-hour traveling checklist at the optimal time of day for observing the species and for optimal observation conditions. So that's things like optimal weather conditions. Now, even with all that optimization to try to make it, give that expert observer the best possible chance of seeing the bird, an eBirder is never going to have perfect detection. You're never going to be able to detect every single individual bird that's occurring in a region. And because of that, with status and trends, we can't estimate true abundance. Instead, what this is an index of abundance that can be used to compare across regions. Okay, so on the right side here, you have a legend. Lighter colors are lower relative abundance, darker colors are higher relative abundance. And you can see down here on the bottom right, the highest colors are associated with a relative abundance of about 2.8 birds. And if you can scroll and zoom on this map, and one of the things that immediately pops out on this particular map is in the central part of the US, you get all these little hotspots of high relative abundance. Those are all large cities in that part of the country. This is the species that roosts in chimneys a lot of the time. So there's high density where there's a lot of chimneys. So that's just kind of like a bit of a sanity check to make sure it's kind of making sense. Also on the legend, for each season, you get a range of dates. These are specific to the species. So for example, the breeding season in this case goes from the 31st of May to the 12th of July. You also have the ability to toggle, if you, for example, you're only interested in the breeding season, you can toggle just the breeding season. I want to pan down to South America. This is a species that spends the non-breeding season in the Amazon mostly. And I want to highlight two things. The first thing is that you'll see there's almost no blue on here, just a few small wisps of that non-breeding season blue. And also you'll see that there's these two different colors of gray. So up here in like Colombia and Ecuador, it's this lighter gray, and then through most of Brazil, it's the darker gray. The lighter gray indicates areas where we're predicting an abundance of 0. So we're predicting absence of the species. And the darker gray indicates areas where there just isn't enough data to make predictions about the species one way or the other. So what's happening in this case is that where this species, the bulk of this species' population spends the non-breeding season is in this area of dark gray. It's in the Amazon. My understanding is this species is typically up at like very high elevation. It's super hard to detect, and our models just aren't able to pick that up. But you can at least see that we're not saying the species is absent from this region. We're just saying that we can't make a prediction for this region. Okay, I'm going to go zoom back or pan back up to the US. The other thing on this page, if you scroll down, you'll see in addition to the visual representation of the data, there's some summary information that you can get at the state or country level. So for example, you can select the United States, and then let's take Alabama as an example. And you'll see it gives you these 5 different summary statistics for the state of Alabama, and then you get each of them for each of the 4 seasons. So the one I want to focus on is percent of seasonal model population. So for example, if you look under the breeding season, it says 5%. So what that's saying is that we are estimating that 5% of the breeding population of chimney swifts occurs in the state of Alabama. There's a bunch of other stats here that I won't delve into, but if you just click the question mark, it'll give you a detailed description of what each of these stats is. One other thing on these regional stats, a lot of people are interested in some sort of custom region that's not a state or a country. And we have implemented a way to get that through the map here. So let's say, for example, we're interested in the population around the proportion of the population that occurs in the city Houston in Texas. On the left side here, there's this draw shape tool. So we'll turn that on, and then we can just draw a circle roughly around Houston. And then you scroll down and you'll see that you get the proportion of the seasonal population that occurs just within that circle. So approximately 1% of the breeding population occurs in that circle. You do have the ability to draw a second shape. So for example, we could compare that to Dallas. And then you see that second state pops up here. And if you click the export data button, you'll get a CSV with with these statistics for these two shapes. All right, next I want to pop over, I'm going to click this zoom to map extent button to go back out to the full extent, and then I'm going to click on the weekly tab. So this is just showing, rather than the seasonal relative abundance, it's going to show for each week of the year what's the relative abundance. You can click on the play button. So right now, you can see the species is migrating. Now it's up in the breeding area. You can see all the US cities kind of popping up, all these little dots across the US. During the non-breeding season, as I said, we're not able to model the species. If you want, you can also you can pause the animation and then step through individually or select a week here. And also, we still have those custom shapes drawn on the map. And on the right side here, you can see for each week of the year, what's the proportion of the population that occurs in those shapes. We sometimes call these migration chronologies. Okay, now we're not just doing this for migratory species, and we're also not just doing this for US species. Obviously, we have 2,500 species here, a lot of them from outside of North America. So as an example, I'm going to show you the species tui, which is an endemic bird to New Zealand. This is just the eBird Explore page for the species. There's actually a lot of useful information here too. You get images and sounds, a description of the species, a map of the eBird observations, as well as the number of times the bird has been observed in eBird. But let's go back to the status and trends page and enter tui. And we'll go back to the seasonal abundance map. So now this is a resident species. So there's not the 4 different seasons. There's just it's a purple map that's showing the year-round relative abundance for the species. You have the same ability here to select summary stats for different regions. Now, I want to show, if we scroll right down to the bottom here, you'll see above the citation, there's this thing that says eBird data from 2008 to 2022. So that means that these estimates were based on models trained using data from 2008 to 2022. And then it says estimated for 2022. We often refer to the versions of these products by the year for which the prediction is estimated. So in this case, these are 2022 predictions. But as Tom mentioned, only about half of the species in here on the Status and Trends website currently are from the most recent release, which is the 2022 release. So for example, let's put in another species, Taiwan partridge. This is an endemic species to Taiwan. You can just ignore these. If you look again above the citation, this one says data from 2007 to 2021 and estimated for 2021. So this is from the previous release, and the estimate is for the year 2021 rather than 2022. So about half the species right now are from 2021, half the species are from 2022. But as Tom said, in the next release that's coming up, all the species will be from the same year, from the 2023 prediction year. All right. I'm going to go back to Chimney Swift. And the final thing I want to talk about is the trends. So currently, we've been talking about what we often refer to as the status products. But we also have trends data products. So these maps are showing the breeding season population trend. I'm actually going to zoom in so you can see it a bit better. They're showing the breeding season population trend between 2012 and 2022, which is listed here. Each circle represents the trend within a 27-kilometer by 27-kilometer region. Blue indicates increase, and you can see there's not a lot of blue on this map. Red indicates a decrease. The intensity of the color, the darkness of the color represents the magnitude of the trend. So if you look at the legend, the darkest reds are declines of over 30% over that 10-year period. And finally, the size of the circle represents the relative abundance in that region. So bigger circles mean areas where there's a higher density of the species. If you zoom over, or if you mouse over any given circle, it will actually tell you the numeric value of the trends, in this case, minus 28%. And then you also get upper and lower confidence intervals. So this is the 10th and 90th quantile for the trend estimate. The white circles are areas where that confidence interval overlaps 0, so we can't confidently predict what direction the trend is. If you are interested in seeing the values for those white circles, you can always click this toggle button and it will fill in all the colors. If you scroll down, we also give summary stats, regional summary stats for the trends data. So first of all, by default, you get a range-wide trend. So the entire breeding trend of the species, the entire population of the species across the whole breeding range, it's declining by minus 13.7% according to our models. And you can pick a region, of course. So you can say, pick the United States, we'll pick Alabama again, and then you see that we're predicting a decline of 19%. All right, and the last thing I'll say is that unlike the status products where we predict for the entire year for the full range of the species, on the trend side, we're only predicting for a specific region and season. So in this case, it's the breeding season in North America. But for other species, for example, let's take long-tailed shrike. So this is an Asian species, and it's a species for which we're making an estimate of the trend in the non-breeding season. So we have a variety of different regions for which we have trend species. So like Australia, New Zealand, India, and Southeast Asia, etc. And the last thing before I hand it over to Tom, if you're interested in downloading just like a static image of these maps to put into, for example, like a presentation, this download button on the top right, you can click that and then scroll down and you can download static images or video files of the animations. I'm gonna stop sharing and Tom's gonna talk about how you can download the spatial data as well that are behind all these maps.
All right, thanks, Matt. Yeah, so I'm gonna kind of go through how to download the data products and open them up in QGIS, which is an open source mapping software. It's fairly similar to ArcGIS if you have access to that, but certainly there will be some differences. So I'm starting at the eBird page, and I'm going to jump to the Science tab and then through to the eBird Status and Trends page. Matt was talking about chimney swift, so I'm going to follow with that example and choose chimney swift. In the top right corner here, you'll see an option to switch from the interactive map to the static map, but also on the right is a downloads. And I'm going to scroll quickly past my key so you all don't see my key and steal all of our data with my key. No, I'm joking. I please hope you all fill out the form and get your own keys to download the data. That way everybody knows what's happening with our data, which is a really important part of our process. There's downloads broken into a few different sections here, and I'm going to walk through each of these and do an example mapping. So at the top are the abundance maps. I'm going to come back to that. And then in the middle, we have range downloads, and then range and abundance summary downloads. I'm not going to talk about that. Those are tables that you can view in Excel or some sort of spreadsheet software. And then finally, at the bottom are the trends downloads, and I'll finish with that. Under range downloads, you can get those individual static maps for either all seasons or by season if you want. But we're going to focus here on this range geospatial data vector file. It's a geopackage format, which is an open source file format for sharing vector spatial data. And so I'm going to download this file here, range vector all seasons. You'll notice that it comes as a zip file. So I'm going to hop into my Finder here, my downloads, and go ahead and unzip my Chimney Swift range folder. And when you open up a range folder, you'll see that there are two geopackage files, one that says range and one that says prediction area. What we've done here is split the data about the bird species out from the background of zeros that we put on our maps, and I'll show you this in QGIS shortly. So I'm using a fairly recent installation of QGIS. I've loaded up a background web map here to just provide some spatial context to what we're doing. But to add data sets in QGIS, you hit the layer menu and then add layer. As I said, with the range boundaries, we're working with a vector, so I'm going to add a vector layer here. And it gives me a chance to choose a file. So I'll hit the menu and browse to my downloads, open up that Chimney Swift range 2022 directory, and I'm going to start with the bird data, the range boundary, and click open. Once that's opened, there's options you don't need to worry about, and you can click add, and then go ahead and close it. And so what you see here is that we have kind of a mishmash of the whole range. You'll see everything, and it's all in one color. It's unstyled. This file is structured in a way that each row, each feature is a different season here. So you'll see breeding, non-breeding, and the 2 migration seasons. So if we want to make a quick range map out of this information, we'll need to do a little bit of styling to make that happen. So to do that, I'm going to go ahead and right-click on the layer in QGIS and hit Properties. It will, by default, pull up this Symbology tab. And QGIS lets you style these by different categories. So I'm going to use this categorized symbolization. And the value that I want to choose for this is that season field in the table. And then at this point, I can click this classify button down in the bottom left, and it will populate all of the values there that are available. So we'll see breeding, non-breeding, post-breeding migration, and pre-breeding migration. I'm going to go ahead and click through to these and choose the colors that kind of more or less map to the colors that we use on the website. So I'm going to use red for the breeding season. I'm going to use a blue for the non-breeding season. I'm going to double click the post-breeding and choose a yellow. And then finally for pre-breeding, I'll click through and choose a green color. Okay, so now that we've defined those colors, and I've clicked apply, you will see that each layer now has a different color, but that maybe the ordering isn't the way we would hope to see it based on what it looks like on the website. So if you keep going down in this menu, there is a control feature rendering order at the very bottom that lets you sort. So here I'm just going to sort by the season, and I'm going to do it in a descending manner. And now the breeding season, because it's alphabetical, pops up to the top, and then non-breeding is below that, and then the 2 migrations. I'm not going to get any fancier than that right now, but just to say that's how you can get these in a GIS and working with them quickly. You'll also notice that this spatial layer doesn't have the square pixel edges that our maps do. What we've done is done a light smoothing on a coarser resolution data to make them a little bit similar to existing range maps out there in the world. But this is how you get these on a map in QGIS. So that's the range boundaries. Let's jump back to the download page here and check out the abundance downloads. So these are the relative abundance downloads. Again, at the top of this download section are the images, those static images that you can use with the legend and the logos. There's an animation as well. And then there's a section here for geospatial data raster, and these are in the TIFF format, the GeoTIFF format. And there's a set of seasonal information and a set of weekly information. So you could download 1 week at a time based on what weeks have passed review, or you can choose seasons. And for different analytical reasons, we've provided both a mean seasonal average or a max seasonal summarization. They have slightly different applications, but we've made both of those available. This all seasons is going to be what we call like a cube, where each layer in the cube is a different season. To keep it simple, I'm just going to download the mean abundance raster for the breeding season for chimney swift. And different than the range, this just comes as a single TIFF file by itself. And even in that preview there, you can see the data is out there. So let's go ahead and add that to the map. So layer menu, add layer, and I'm going to hit this add raster layer. So this is not vector data, this is raster data. It's on a uniform grid. And I'm going to navigate to the downloads here and choose my chimney swift abundant seasonal breeding mean file, TIFF file. And again, there's no necessary options there. So I'm going to add that to the map. The first thing you might notice is that you're not seeing the data you're kind of expecting to see. You're seeing a large amount of black areas. These are the zeros that are in the background of the map. And it can make it tricky to style these maps in QGIS right out of the gate. So the first thing we're actually going to do once we download it is process it a little bit to make a copy of it that removes the zeros. So in the top menu, there's a raster button. At the bottom is a conversion. And then at the bottom of that, there's a translate. And this is very simply just creating a version that converts all zeros, true zeros in the file to NA or no data. And so I'm going to go ahead and set that no data value to 0. Click run. Takes a second. And then I'm going to close that and untoggle the file I originally loaded. And there we go. Now we only see the values for chimney swift that are above 0. But they're still not styled. They're just black. So what we're going to do is go into that symbology menu for this converted layer. And the default in QGIS is this rendering of single band gray from black to white. We want to add some color to it. So we're going to use this single band pseudo color. And what we're going to do is take this color ramp here, and I'm going to go ahead and choose the one that we use on the website for our weekly information. And it's under all color ramps, and that's plasma. You could use whatever you want. I'm going to invert it so that it looks like the one we use on the website, so that yellow is a low value. And I'm going to go ahead and just start there. I'm going to apply that. And what you'll notice is that, yep, you've changed from black to yellow, but it still doesn't look like our maps on the website, and that's because of the color classifications that are used on our website for this data. This data for chimney swift is very skewed to be really heavily around urban areas where they're concentrated in large numbers. And so if you squint at this screen, you can see some more red colors near cities. But if we want to visualize this in a more compelling way to deal with that skew, and also to match the fact that our relative abundance estimates are really good in terms of their rank order, this is part of their relative nature, is that a quantile representation really helps. So back in that symbology menu, under mode, the default was continuous. I'm going to switch this to quantile. And I'm going to bump this up to just about 24 bins. That's what we use on the website. And so now you'll see that these values are a little bit more spread out. There's more small breaks across the color, and the big values don't come until you get to the very end. So I'm going to go ahead and click apply. All right, so now you're starting to really see the spatial pattern in the data. That rank order of relative abundance that we're modeling really pops out. You can see the urban areas and some of the places where the species is persisting in more natural environments as well as dark purple colors here. If you want to go ahead and put those zeros in the background, you can toggle on that original layer before we transformed it. And I'll just go ahead and hit the properties here real quick. And I'm just going to choose a unique value here. Wait, nope, I'm going to use I'm going to use a paletted unique value, and I'm just going to add, just click a plus here to add 1, and it's 0, and that's fine. This will turn it all gray here in just a second. There we go. So they're not quite the same gray we use in the background of our maps, but I think you get the idea. Those values can represent the 0 predictions that we're making in our maps and for our visualization. So that's kind of a quick start guide to getting an abundance raster layer into QGIS, processing it so that it has just the positive values in one layer that you can style nicely with a quantile classification. Okay. Matt and Andrew aren't bugging me with questions from the audience, so I'm going to keep going and go with trends. Okay, so similarly to the range spatial data that we looked at earlier, trends is stored in a geospatial vector format, not raster. It's a geo package. You can see that there's a download for the map. There are some summaries of the trends in a CSV, but what we want in the middle here is this trends geospatial data vector format. And I'm going to go ahead and download that. I'm going to jump back to QGIS here. Actually, sorry, I'm going to go to my downloads. This is also a zip file, and we'll talk about what files are in there, but I'm going to unzip this Chimney Swift eBird trends zip file. There's a metadata document you can open in the markdown format if you want to look at that. There's a CSV of summary information talking about the predictive performance, the performance of the model. And then there's a geo package for the data itself. So back in Q, I'm going to hit that layer menu, do add layer, add vector layer. And this time under my downloads, I'm going to go into the trends folder and choose that trends geo package. Click add. All right, so what you notice right away, right out of the gate, is that we get a bunch of circles, like the maps on our website. This was the format that we thought was the easiest for GIS folks to use and for people to make maps quickly out of this data. If we right-click and look at the attribute table for this file, we'll see that it also includes lat long and the grid ID. So if you want to do some fancy moves in the R package, you can convert this to a grid. If we look through the columns here, we'll also see that there are a couple of different useful fields in here. There is the abundance value at each pixel, which we're using to size the circles. But we're also providing this data as a % per year, which is not how it's visualized on the website. But a lot of quantitative ecologists and statisticians like to analyze the data in that format. So what is the % per year change in the population over on average over the period of analysis? What we do present on the website is a cumulative trend, how much it's changed from the start year to the end year. And so for the demonstration purposes today, I'm going to show that value. But there's a lot of information in here that you can look at in a variety of ways. Okay, so let's get this styled. I'm going to right-click on the properties, go to the symbology, and we're going to use a graduated symbolization this time. And we're going to use that abundance trend field. One little thing I'm going to do to make these look nice is I'm going to go into my symbol and configure my symbol to remove the outline on the circle. Optional move, but one that will make it look like the maps that we create. And then I want to choose the color scheme that looks like our website. You could also choose other diverging color schemes. You know, there's ones here like brown to green, but I'm going to stick with this red to blue color scheme so that it matches the website. And then we want to classify this. And what's a little tricky about this is we want to have the middle of the symbolization be around 0. So we're going to use this equal interval option. And you'll see when I first click equal interval and it provides them, it has this middle field here where it's crossing a very large range of values. That's what this symmetric classification option is for in QGIS, is I can choose a midpoint of this color scheme. And I'm going to set that to 0. And then I'm going to go ahead and bump up the number of classes to 7 so that I can make the bins match the bins that are on our website right now. So once we have 7 different breaks, I'm going to go ahead and just double click these. So we do -30 or less than as one bin, -20 to -30 as another, -20 to -10. And -10 to 0, and then we'll go out the other side, 0 to 10, 10 to 20, 20 to 30, and 30 or greater. All right, so now we've got a symmetric set of bins that is matching the website, and the colors are going to be pretty close to the colors we use, so I can go ahead and click apply. And then you will see that this map should very closely match the map that we're creating. But this is just kind of a quick start guide of how to get it into QGIS, get it looking kind of like how we've set it up. And then, mapping from that point on is up to you. So unless there are specific things I should re-highlight or focus on, I think I can pass it back to Matt.
Yeah, that's good.
Thanks, Tom. That was actually kind of useful for me too. I'm not much of a QGIS user normally. Okay, I
answer
Wait.
one.
1 second.
Oh, I just want to jump in so that Tom can answer one question that comes up a couple times, which is there any reason to use QGIS over ArcGIS for uses like this?
The only reason I have is that QGIS is free to download. If you have access to ArcGIS through a university or something like that, it has all of the same features, but it does cost money.
Okay, I am a little cognizant of the time, and I want to leave time for the R stuff, but I do want to actually just very briefly revisit the trends. Oh, what happened? Sorry. I just want to. Okay, so you should be seeing the website for long-tailed trike. I want to clarify a few things related to trends. So on the status side, for the relative abundance estimates, we always try to estimate for the full year and for the full range of the species. So, for like a globally distributed species like barn swallow, we try to estimate relative abundance everywhere. That's not the case for trends. So I'm going to go, so you see for this species, it's all throughout Asia. But if you go to trends, you'll see that it's only for certain parts of the full range. So for example, we're not trying to estimate trends in China, as well as Indonesia and some other places. For the trends, it requires a fairly large amount of data to get the trends right. And the amount of data in eBird is highly variable between regions and between years. So to try to do as good a job as we can at estimating trends, for a given region, we only estimate the trends for the sub-regions of that region that have enough data that we think we can have a good shot at getting the trend right. And that also applies to the range of years. So you may remember from the chimney swift example, the trend was estimated from 2012 to 2022. But for this species, it starts in 2014. And that's because prior to 2014, in the US, we had enough data to estimate the trend for chimney swift, but there wasn't enough data prior to 2014 to estimate the trend for the species in this region in Asia. Okay, I just very briefly wanted to talk about that. I'm now going to transition. So Tom spoke about QGIS, and I think especially for things like making maps, QGIS is a great tool. But there's a lot of applications where you're trying to do more advanced things with the data. You're maybe trying to process a whole, like a large number of species all at once, or you want to have some kind of a reproducible workflow. And for a lot of those applications, it can be really valuable to work with the data products in R. And we've developed this R package, eBird ST, that's specifically designed for that. This is the website for the R package. I'm going to ask Andrew to post in the chat the link to this website. So the front page of the website has some basic info about how you install the package, and then also how you set up data access for status and trends. We'll talk a little bit more about that in a second. And then what I think will be particularly valuable for everyone attending is under the vignettes dropdown, we have 3 different vignettes. So these are just basically tutorials for doing different things. This introduction vignette will go through just like how you access the data, how you download the data, also like what are the various types of data available, just a variety of introductory information. And then if you go to the eBird status data products applications, this one has a handful of simple examples of really common applications that people frequently want to do. And we're going to cover some of these applications shortly. But one that we're not going to cover that is in here is a whole section on how you make maps of relative abundance using R. So how you could kind of make a map that looks like this, for example. I think often it's easier to make maps in QGIS, and to do it in R can be quite sort of complicated and a little bit annoying. So we're not going to cover it today, but there is information about it there if you're interested. And finally, we have a vignette on the trends data products. We're not going to talk about trends today or next week, but in the 3rd webinar, it will be totally devoted to trends. Okay. Oh, and then finally, we have a change log. This is a pretty technical document that talks about, for each version of the data products, what are all the things that changed between that version and the previous version? And it's everything from differences in the eBird checklist included to the different covariates we use in different versions, as well as changes to the base model. All that information is here. There's a lot of really useful stuff in here, but it is fairly technical. This is a good opportunity to point out that because of all of these changes between years, it's really important that you never try to compare, say, like 2021 to 2022, because there's been a lot of changes to the model between those years. If you see a difference in relative abundance, that difference may have more to do with differences in the modeling process than it has to do with differences in the underlying populations of the species. So you should only ever work with one year at a time. Okay, going back to the homepage. So to access the status and trends data, you need to fill out a form just to say essentially what you intend to do with the data, and then read a terms of use, and then it will give you an access key. So if you're on this page and you click this link here, it will take you to that form. Or if you've already submitted the form and you have access, it will bring you to a page like this that has your access key written down. And now I'm going to transition into R. But before I do that, I'm going to copy this access key. Now I'm going to share my R screen. Okay, so you should be seeing my
Matt,
yeah.
do we want to pause and do the poll?
Oh, yes, good call.
Okay. But all right, so we're gonna launch a brief poll, take a break, just a pause, breathing point here, as we're switching from non-R to R, and Matt enters into the live coding. We've got 4 questions. I'm going to launch the poll now. If you please take an opportunity to answer these 4 questions, it would really help us out. So I'm launching the poll. Here we go. Okay, and we'll leave this up for, let's say, 3 minutes. 3 minutes. We got 4 questions. What's your comfort level? Do you have experience with R? How do you plan to use it? And then really maybe think the one that we're all really excited to get an answer to is number 4. Is there a place we could start a forum for discussions about this that would be convenient, and which of those would be helpful to folks? So please take a moment. We'll leave this up for a few minutes and give everybody a brief break. It's got one for me. Okay, we're still getting the answers coming in, so I'm gonna give it 1 more minute here.
Wants an old.
Should we move on?
Yeah, we've got 90% responded. Thank you all very much. So I'll go ahead and end the poll. We appreciate it.
Great. Okay, so you should be seeing my R screen now. We're going to work through an R script, but which I'll share momentarily. But before we do that, you remember I mentioned the getting the poll popping in.
There was an option to share it. I thought it would just like put it in the chat, but it like makes it live, so I'm stopping.
Oh yeah, no worries. You remember I showed the how you can find your access key for eBirdST. The first thing you have to do after you install the R package, eBirdST, is to set that access key in such a way that the R package knows about it. This is something you just do once. The access keys do expire, so once they expire, you'll have to do it again. But you don't do this every time you use the package. So you first load the R package, the eBirdST R package. So I'll load the package, and then the function is called set eBirdST access key. And then in quotes, you just paste your key. Obviously, this isn't my real key, but you would put your real key in there. You hit enter, and then that will store the access key so you can access it in future. All right, so I'm going to ask Andrew to post the link to the R script now. And I'm going to work through an R script with some examples, and I'll be writing code as I go along. But the fully filled out script will, Andrew's going to post a link to that if you want to copy that.
Sorry, Matt. We neither of us have that.
Oh, okay. No, I can post it. 1 second.
Also, just a housekeeping note, if you are raising your hand, we're not planning to pause for open mic questions from the audience. So please put your Q&A in the Q&A section, not the chat section, as that's how Andrew and I are handling the questions. Thank you.
Okay, I just posted that R script. So we'll see how far we can get through this. The idea here isn't really for you to kind of write the code along with me, although if you want, you can try. But since you have the script, you can run it after the fact. And these examples very similar to this are also on the package website. Okay, I'm gonna start by. I'll also. One more thing I'll also mention, if you're someone who attended it and who's not very familiar with R, you're welcome to drop off at this point, but you can also hang around if you're interested. I'm going to load a variety of R packages that will be useful for the examples here. The most relevant one is this one here, which is eBird ST. That's how you access the data. And then we have a couple packages, SF and Terra, that you use to work with spatial data in R. So the first question you may be interested in is what species have status and trends data products? So you can use, but there's a data frame called eBird_st_runs. I'm just going to use the view function to open it in sort of like a tabular format. So you'll see there's 1,118 species here. These are all the species that we released in the previous year. The R package only deals with 1 year at a time, so only the 2022 releases in this R package. And you get the common name, the scientific name. These are the 6-letter species codes in the far left. There's a true/false value indicating if it's a resident or a migrant. And then the interesting stuff is here. For each season, the results are reviewed by an expert, and that expert sets the seasonal dates. You saw those already on the website, and they're listed here. So for example, for Acadian flycatcher, these are the breeding season dates. And then you also get a quality score from 0 to 3. 0 basically means that the reviewer looked at that season for that species and deemed that it was too poor to even release. And then 1 to 3 are sort of like stoplights. They tell you something about the amount of extrapolation or omission occurring for that season. So a 1 is like a red light. It's something to be quite cautious if you're going to use. It means the results are fairly low quality. There's probably fairly extensive extrapolation or omission or noise. But some regions probably have estimates that are accurate. The yellow light is medium quality. There's a bit of extrapolation or omission that's sort of used with caution. And then a 3 is a green light, sort of quite high quality. There's very little issues, and you can sort of safely use these without too much worry. So those values are available for each of the 4 seasons: breeding, non-breeding, post-breeding migration, and pre-breeding migration. For residents, we don't have the seasons, obviously, but we just give 1 quality score for the full year. Finally, on the far right, there's a bunch of stuff related to trends that we'll talk about in the 3rd session. If you want to look at the results just for a single species, you could filter that data frame. This is using dplyr syntax. You could say common name equals chimney swift. Oops. And this gives you just that single row. A nice way to look at that is using the glimpse function from dplyr, which puts it in this long format. So you can see, for the breeding season, there's a score of 3, but for that non-breeding season, there's a score of 1. All right. Next, I want to talk about, you've seen the list of species, you've picked a few species you're interested in. How do you access the data? The relevant function for downloading data is called eBird st _download _status. So I'm going to look at the help for that function. So here on the right, we have the help. This downloads data for a single species. So on the first argument is the species. It could either be a common name, a scientific name, or that 6-letter eBird species code. The second argument is the download, the location that you download it to. eBird ST is designed to do all the managing of the data for you, and it by default sticks the data in sort of a somewhat hidden location specific to this R package. I really strongly recommend, unless you really know what you're doing, just leave this alone. It's some specific directory on your computer. If you're interested in finding it, you can call this function. But it's basically not relevant, and it's best that R does all the managing of everything. Then you'll see there's a whole bunch of these download underscore arguments. There is a massive amount of data for every species. A lot of it is not relevant for most people. Most people just want the relative abundance estimates. So by default, you'll get the relative abundance estimates. But there's all this other stuff that we'll talk a little bit about in the next session. And you can control which of those things get downloaded. And finally, there's a couple arguments down here that are relevant. If you use the dry run argument, it will, rather than downloading, it will just list all the available files. So for example, we could say eBird st _download _status. We could put in, let's say, golden eagle. And we could try dry run equals true. And you'll see you get a long list of all the files that are available for download. Didn't actually download anything. There's a bunch of stuff in here, and we'll get into more detail in the second session about some of the more esoteric products. But the main thing to note is that there's a bunch of products that start with seasonal. So these are the seasonal relative abundance estimates. And there's a bunch of products that have weekly in the directory structure. These are the weekly relative abundance estimates. And then also you'll see these are in TIFF format. These are GeoTIFFs, the same format that Tom used in QGIS. And then you'll see that every file has 3 versions. There's one that begins at or ends with 3 kilometers. So those are estimates at 3 kilometer spatial resolution. That's the native resolution that we make predictions. But we also provide estimates at 9 kilometers and 27 kilometers. Those can sometimes be useful because these rasters are quite large. So especially if you're dealing with a huge number of species, it can be challenging to work with the highest resolution data. And it might be worth dropping down to like 27 kilometers for your application. All right, so let's actually download some data. Let's download the golden eagle data. And there's a final argument called pattern, which will just download the files that match some text string. So I'm only interested in the 3 kilometer estimates. So I'm going to say pattern equals 3 kilometers. I'll run that. And you'll see that it said that the data are already downloaded, so it's not going to re-download them. But if you hadn't downloaded the data, it would actually download all the files. And I'm going to do exactly the same thing for a resident species, just as an example. So I'll put that here. We'll do that TUI that we talked about on the website. So let's say we download both of those data sets. Okay, so now you have the data on your computer in some directory. The next step is to load it into R. The function that we have for loading this raster data into R is called load raster. And again, let's just look at the help for that function. So there's, like I said, there's a whole bunch of different data products here. And this function can load, you can specify, any of those combinations of things. So for example, you can load the count, occurrence, or abundance data. We're only going to talk about abundance today. Using the period argument, you can specify whether you want weekly or seasonal results. And then using the resolution argument, you can say whether you want the 3, 9, or 27 kilometer results. So the default is just to load the 3 kilometer weekly relative abundance. So if you just put in the species name, that's what it'll do. So I'm going to call this abundance weekly. So it just loaded. I'm going to show what this looks like. This is a raster stack that's accessible via the Terra package in R. There's 52 layers. Each of those layers corresponds to a different week of the year. This tells you the resolution. So it's about 3,000 meters, 3 kilometers. And then you also get down here, it shows the names of each of the layers. So each layer is named according to the midpoint of the week that estimate is for. If you want to see what those weeks are, you can call names and then the name of the object, and it will give you that full set of weeks. Okay, so for example, you can do things like, let's store that list of weeks as a variable, and then you could, for example, subset to just the weeks in May. So just in the interest of time, I'll just sort of paste in what that would look like. So you can use the double square brackets notation, and then we'll say, that weeks is greater than the 1st of May and less than the last of May. So if you run this, and then let's see what this looks like. This just has 5 weeks. These are the weeks that occur in May. And if you want, you can do things like, average across the weeks in May, just using the mean function. That'll probably just take a second to run. Okay. So this is an example where we're working with a 3 kilometer resolution data. So it's a lot of data to process all at once. So here you have just a single layer now, and that's giving you the mean relative abundance for the month of May. And then the next thing I'll show is you can, for example, load the seasonal data. So abundance seasonal equals load raster. We put in the species name. But this time I'll put in period equals seasonal rather than weekly. You can see this is a raster that has 4 layers, 1 for the breeding, non-breeding, pre-breeding, and post-breeding. If you want to subset to just a single season, you can, just using that double square brackets notation, just type the name of the season. And now you just have the breeding season relative abundance. Okay, I'm gonna skip ahead through this little bit here because it's not super relevant. Basically, for residents, you can get the that full year, a raster for the full year relative abundance rather than the 4 seasons because they're non-migratory. So I want to jump ahead to an application. One of the most common things that people want to do is know what the regional proportion of population is. for a region of their choosing. So on the website, you can get either the country or the state population, and you can also draw a polygon for a region of interest to you. But often it's the case that you might have like a protected area that you manage, and you have a shapefile that has the boundary of that protected area. You want to know what the proportion of the population is that falls within that protected area. So this is how you would do that in R. So let's start by loading that seasonal relative abundance, because we want to know the proportions of population seasonally. I'm going to do it for golden eagle. Remember, I go period equals seasonal. We get the seasonal relative abundance. This next little bit of code I already have written out. This just grabs a boundary for Wyoming. So let's just say that for this example, we want to know the proportion of the population within the state of Wyoming. It gets it using an R package called R Natural Earth, and it's a great source for like boundaries of states and countries and so on. So the first piece of information we need to know is what's the total relative abundance across all of Wyoming. So we can just sum up the relative abundance of all the cells that fall in Wyoming. The Terra function that can do that, we're going to call this Wyoming abundance, is called extract. We'll give it the seasonal relative abundance. We'll give it the Wyoming boundary. And then we say function equals sum, meaning that we want to sum up the relative abundance estimates for all the cells that fall in that polygon. Oops. We want to remove the missing values. And finally, I'm going to use this weights equals true argument, which will handle cases where the polygon only partially overlaps a raster cell and include just the portion of that raster cell that's within the polygon. Let's run this. And we should get some list of values. This is, the total relative abundance for each season within Wyoming. Now, to get the proportion, we need to then divide that by the global total across the entire raster. And we can get that. I'm going to call it total abundance. You can get that using the global function, say abundance seasonal function equals, again, sum. Again, we want to remove the NAs. See what that looks like. Okay, so here now we have the totals across the whole raster. And the next step is just to divide the two. They're in a slightly annoying format where one is in a long format and the other is in a wide format. So I'm just going to paste in a little bit of code that will divide these two values, these two sets of values. And okay, so you can see here that this gives you for each season of the year, the proportion of population that falls within the state of Wyoming. So for example, during the breeding season, we have about 2.5% of the population in Wyoming. And that's the global population. Remember, this is, for those of you who don't know, this is a species that occurs both in North America, but also in like all throughout the old world as well. As I continue on here, I'm going to ask Andrew, do you think it's worth continuing with this example and then doing questions, or just sort of pausing for questions?
Let's do a quick pause for questions in case there's questions about what Matt has shared so far. If you have questions, I think go ahead and put them in the Q&A. Tom and I will keep working on them. And then Matt, maybe we should take a 3-minute break and then you can jump back into the next section.
Sure. One question I'm seeing here in the chat is someone said they can see abundance for some species on the website, but not in the R package. That's because remember that the website has abundance estimates for two versions, the 2022 release and the 2020 release. The R package only deals with the most recent version, the 2022 release. So you're going to end up with about half of the total number of species on the website.
Matt, one thing that's coming up. Somebody's having trouble with the Wyoming boundary.
What is it saying? Is it in the
It's in the Q&A. It's error in evaluating the argument X. Here, I can put it in the chat. Maybe you'll recognize it.
Oh, this right. I'm guessing. I'm wondering if they have an outdated version of the R Natural Earth package. Seems like this is old versions of the R package were relevant to we're meant to work with the SP package, and then new versions of the package are meant to work with the SF package.
One also question of what you've been working on right now is somebody wanted to know what if, like from the Wyoming example, what if you wanted multiple states? Maybe you could talk about that.
Yeah. So for the multiple state question, you can use basically the same, almost same approach. You just have to kind of keep track of both the state and the season. And I do actually exactly that on the eBird ST website in the second vignette. This example is covered there, and I do the proportion of population across all states.
All right, Matt, it's been about 3 minutes. I think we're ready to jump forward, and Tom and I will keep working on the Q&A.
Okay. So yeah, I realize that this is all going a little on the long side. Obviously this is the first time we've done something like this, so perhaps it was inevitable. So I'm just going to keep going, try to get through this example. Hopefully, if you're able to stick around past the 1:30 mark, then we'll be here as well to continue asking, to continue answering questions. Okay. All right, so I mentioned that golden eagle is quite a broadly distributed species. It's sort of like in northern latitudes across the whole world. There's a lot of cases where what people really want to know is not the proportion of the global population, but the proportion of the sort of continental population. So in the case of golden eagle, maybe you're interested in what proportion of the North American population occurs within the state of Wyoming. And in fact, in the next year's release of the status and trends on the website, we will actually add that information directly to the website. So you'll be able to see for each continent what proportion of the population falls within different countries or states. But let's show how to do that here. So first, I already just have the code here to get a boundary of North America from the R Natural Earth package. So I'm just going to run that. This is sort of the broad definition of North America, including Central America and the Caribbean. So the first thing I'm going to do is I'm going to use the mask function from Terra to take that seasonal relative abundance raster and mask out, remove all the values that are outside of North America. So I'm going to call this abundance seasonal North America. The function is masked. I'm going to give it the seasonal relative abundance, as well as the second argument is that North American boundary. So I'll run that. And It'll just take a second again because it's sort of higher resolution data. You can actually plot these things in R. It's not worried about that. Oh, that you can sort of see it on the right side. They don't look very good by default, but you can see now there's just data for North America. And now we basically just do exactly the same thing we did before. Now, again, we just sum up we already have the Wyoming, the total relative abundance for Wyoming. So now we just need to know the total relative abundance for North America. And we can again just use that same global function, but now it's applied to this masked relative abundance raster. So instead of getting the total global population, we're going to get the North American population. So I'm giving it that masked raster as the first argument. Just as before, the function we want to do is sum. We want to sum up all the cells in the raster, and we want to remove the missing values. Okay, so again, it's a data frame that has one row for each of the seasons, and I'm going to do that same thing of just dividing the Wyoming population by the total North American population.
Hey, Matt.
Yeah.
Just one thing that'd be helpful maybe for you to elaborate. One of the questions was about when you're applying that sum function. They're asking, you're just adding the abundance values of the region together, right? Could you talk a little bit about the interpretation of the values there?
Yeah, sure. So yeah, this is literally just summing up all the relative abundance values for every cell in the raster. And in this case, the raster has been masked. So it's just the cells in North America. So, remembering that these are relative abundance values, they're not true abundance. So it's not giving you something like the total number of golden eagles. This isn't saying that there's 23,474 golden eagles in all of North America. Remember that relative abundance is an index. So it's sort of hard to interpret what this number means on its own, but when you divide values from different regions, then that's when you can draw some interpretation. So by dividing the total from Wyoming and the total from North America, we can get the proportion of the population that falls just within Wyoming. Oops. I had a typo there. Okay. That works. Okay, so I did that division, and we now have the proportion of the population in Wyoming, the proportion of the North American population. So now instead of, I think before it was something like 2.5%, and now it's almost 10%. So obviously it makes a huge difference. And for a lot of conservation applications, what you're interested in is, is maybe understanding the portion of the population sort of like maybe within a given flyway or something like that, rather than the proportion of the population globally, because you only really have control over that flyway. All right. I could do one more example about chronologies, or we could sort of stop here and talk about, sort of do like the wrap up and then do questions. What do you guys think?
I think should.
I didn't quite catch that, Andrew.
Sorry, we're deliberating here.
Yeah, it's 1:30, so I think Matt, if you're at a natural breaking point, I think this is a good place to stop with the live coding. We'll spend some more time doing questions. We can also start to kind of put some of the questions that we see in the chat out live and kind of discuss them among the three of us.
Cool.
So the live session kind of ends now, but we can continue to stay on it, and we'll be here until 2 p.m. Eastern time. So for another half an hour to answer questions.
Cool.
Yeah.
And
So-
I'll just say, if people are really interested in the final example, I can always do it like closer to 2 or something like that for those of you who are sticking
Okay.
around.
There were a couple of people in the chat who said woohoo chronologies.
Okay, I'll do it. So before I stop sharing this R screen, at the bottom of that R script that you have access to, I have a couple of homework exercises. I think it would be really valuable for folks on this webinar to actually try doing something, even if it's something simple, because by doing something, you're gonna encounter issues and errors, and then in the next session, we can help you with those.
Hey, Matt.
So, yeah.
Let's do the Google form before we start losing people since
Yes.
we're transitioning.
Okay. Do you want to post that, Andrew?
Do you? I can get it.
I got it.
Oh, you got it. Okay. Yeah. So we've got a
Andrew's. Oh,
yeah,
good.
go ahead. You say it, Matt. You put it together.
Oh, yeah. So Andrew's just going to post a link to a Google form, which we're hoping that you all can fill out. There's basically just like 3 really simple questions. The first one is, do you have any other questions that weren't addressed here from today's webinar? Next, we really want the second webinar and the third webinar to be based on examples and applications that you submit. So there's some text, there's a text box there that you can, if you think there's an application that would be of interest to cover next week, you can describe it there. You can also put in your email so that I could even potentially reach out to you and get further information. So that would be super helpful. And then finally, as you're working through this script, if you run into any like technical challenges that you think would be useful to bring up in the next session, you can also enter them. There's a question about that. And we're hoping you can try to submit this by the end of the day on Monday, so that we can prepare for the webinar on Thursday next week. All right, and then the final thing I was going to say on this R script is, I have these 2 homework exercises. The first one will literally take you 3 minutes or less. It's just running this little bit of code. This is just going to check that you've installed the R package correctly, and that you've set your API key correctly. So you will need to load the eBird SDR package and then run this line of code, and it should give a list of a whole bunch of files that you can download. So at the very least, hopefully you can try to do that. If you have any problems, send me an email right away. Andrew, you can post my email address in the chat. And then the second question is slightly more involved. It's just basically doing what we just did for the proportions of populations, but for your own species and region. So I'm going to stop sharing. And then I guess, we can kind of go to some questions now.
I don't know if Scott Walters is still on, but I think in the chat I got the feeling that you solved your Wyoming boundary script issue by declaring the vect function explicitly from Terra, but I'm just following up on that. Here's a question. Is it easy enough to mask custom geographies? E.g., can I mask only California least turn from the bin of all least turn, and then mask the portion of California we manage from all of California? Is there any limit to the masking?
No, as long as you have like a polygon for the region you're interested in, you can mask it however you want. And that can either be a polygon that you get like a state polygon, the way we did it here, or you can read in a shapefile or some other spatial file that defines the polygon.
Yeah, the only limit I would say is that if your polygon is smaller than 3 kilometers by 3 kilometers on the side, you're not going to get very much information about it. Unfortunately,
it sounds like Scott maybe was not able to resolve that issue. Maybe either if you're able to stay towards the end, we can work on it. Otherwise, send me an email and I'll respond right after this and we can figure it out.
Matt, is there a way to get a list of species for for like a custom region, Europe or the Middle East? The only way I can think of doing that is using the filter on the website, but then you can't download it as a species list.
Yeah, there is not. That's actually a really useful feature, and I wonder if we could think about trying to implement that in some way. The one thing that comes to mind is that you can download the regional summary stats for each species, and then you could use that to see like what species occur in what countries or states. But I maybe we could set it up so that you could download that file for all species, and then use that to like subset to just the full set of species for a given area.
Okay, Matt, we're gonna try to answer this per year. There's a question here about understanding correctly that per year needs to be done separately and with caution. How seriously different are those per year models in terms of inference? You're nodding and assuming I think I'll answer it.
Yeah.
So yeah, basically the individual years of status products that we release are not safe to compare across years because there are too many differences in methodologies and prediction values. So it's not safe to compare those. Most of the differences between years right now are probably coming from those changes in methods, which are listed under the change log, and we can type an answer to that. We are working on trends products that do describe annual relative abundance while controlling for a variety of factors, but that is an active research topic.
Tom, while you're on, I'd also like to answer an additional question live about multi-species analyses. This is a really good question that I think a lot of people ask, where because each species level relative abundance layer, it's standardized to the detection effort covariates for that species. And so it is really tricky and often not advisable to compare relative abundance between different species directly. So if you're interested in doing multi-species type analyses, like one where you might want to stack up different rasters, I think there's two strong ways to do this. The first and more simple way is to convert the data to presence absence. So now it's 1 and 0, and then you can start to do the sorts of analyses that use species richness information. The second way, if you do want a quantitative metric that's standardized between species, that's the percent of population or proportion of population layers that Matt, I think you were talking about those earlier, correct? Those are available in addition to the relative abundance layers, both from the R package and directly from the website. And that is a number that's standardized between species because every layer for every species now adds up to 1 or 100. I don't remember if it's proportion or percent. So one thing that we have seen a lot of people use is kind of stacking up different species, but weighting each raster grid cell by the percent of population. And that gives you kind of a window into like the ability to start doing diversity-based or richness-based or abundance-based diversity metrics.
Yeah, thanks. And that's just to like be clear, like that's exactly what the kind of stuff that we'll work on in part 2 next week is using this proportion of population layers and doing like multi-species analyses.
Also, folks, if you've been replying to a reply in the Q&A under the answer section, I don't think Andrew and I have been able to keep on top of that, but we will comb through at the end and follow up if anyone has done that and had follow-up questions. I'm working on it now.
It does also seem like there was a typo in the script I posted, which I've now fixed and updated the script on GitHub. So if you just refresh your browser, the browser window that has the script, you should get a corrected script.
Thank you, Matt.
Should I do another example if anyone's interested, or do we have any more?
I mean, did you do the chronology? Sorry, I was deep in questions.
No, I have not done chronologies yet.
What do you think?
I don't think it'd be fair to do them now and not do them for the people that have left already, because we're past 1:30. But Matt, I think it'd be fine, like, as long as you don't do anything that you won't do next week, I think it'd be
Yeah.
fine to show some of that stuff. We just would have to repeat it next week. There's 2 more questions in the chat though that we can answer live. Matt, a question for you. What is the best method for finding the projection and coordinate reference system for the rasters downloaded from Mars?
Yeah, so I'm gonna, oh, I guess I'm not sharing anymore. I'll reshare my screen. Okay, so if you just inspect one of the rasters we downloaded, so let's say abundance seasonal, you'll see that it gives you all the projection information here. If you want to get you know, specifically just the projection information, you can use that CRS function on that object. And it's giving it to you in this well-known text format, which can be a little bit hard to parse. But basically for the results currently in the R package, it's using kind of a weird sinusoidal projection. It's the same projection that the MODIS satellite data comes in. And then it's an equal area projection, which is the most important thing. And then, but next year will actually be in the equal Earth projection, which is also equal area, but it's a lot better for mapping. The sinusoidal projection is like quite distorted and skewed, so you can't really use it to make maps. If people are interested, you can also use the STCRS function and say abundance seasonal, and I think you can then go $ proj4 string. This may or may not work. Yeah, and that gives you the sort of more standard proj4 string representation of the coordinate system. I see there's still like 160 people here, so I don't want to. I feel like I may as well just continue on with. I'll just run this migration
Well,
chronology
we have
example.
hey Matt,
Nope.
we might do just a live answer here about a question.
Yep.
So can you tell us about the quality of the relative abundance data? How does raw data availability affect the estimates? I know trends have some sort of data quality measurement. Is there anything like this for abundance data? Yes, it's kind of not at this current moment very well documented, but it is. Matt, please correct me if I'm wrong. Are the predictive performance metrics in the current version? Are there predictive performance? Yeah, okay. So there
Yeah.
are spatialized predictive performance metrics. Is one of the things you can download for each species. So if you're familiar with modeling predictive performance metrics, there's a lot of common measures in there. In the version coming up, we're about to increase the number of those and spend more time developing some vignettes explaining how those work. You know, there's things like AUC values and correlation coefficients and stuff like that. So yes, that is available spatially as well. But we haven't provided a lot of official guidance yet at this point on that. Yeah, I guess if you want to go ahead and then, Matt, yeah.
Sure. It'll just take a couple minutes. Yeah, so one of the other kind of common applications is people often want to see for a given region to see a migration chronology. So it's essentially like a line plot that shows you throughout the year how the abundance for that species changes in that region. Obviously most relevant for migratory species. So for this example, I picked hooded warbler. For those not from the U.S., it's a small, or sorry, for those not from North America, it's a small, cute yellow and black songbird that's migratory. It breeds in the eastern part of the US, and then it spends the winter, the non-breeding season down in Central America. So let's create a migration chronology for this species for the Central American country, Guatemala. So, we haven't yet downloaded the data for this species, so we'll start by saying eBird st, download status. You can type in the species name here. Often I'll use these 6-letter species codes, it's the first column in that eBird st runs data frame. So you can, for hooded warbler, it's HOOWAR. And then I'm going to use that pattern argument again. I always try to use that because if you don't use the pattern argument, it's going to download everything. And that can be just like a huge amount of data, like many, like hundreds of megabytes, when really you may only just want like a single file. So what I want is the weekly relative abundance estimates. And to do that, I can use the pattern abundance median, and I want the 3-kilometer estimate, so I'll put the 3-kilometer in there. And remember, you can use that dry run argument here to get the list of files, and then you can see from the file names what kind of pattern argument you might want to use. So I'll run that. I pre-downloaded this data, so it's already there. Again, I'm getting a boundary of Guatemala from the Natural Earth HAR package. So that's just a boundary polygon for Guatemala. So now the idea here is, we want to load that weekly raster data set and then do the same thing or a similar thing to what we did before, which is to summarize for each layer in the data set over the polygon for Guatemala. So first I'm going to load the data set, abundance_weekly, I'm going to call it, load raster. And again, I'm going to use that 6-letter code. By default, this function will give you the weekly 3-kilometer relative abundance. So I don't need to specify any additional arguments. Okay, so I'm going to call this thing abundance_GT for Guatemala. I'm going to use the extract function again. I'm going to give it, the first argument is that weekly relative abundance raster. The second argument is the polygon, the boundary polygon for Guatemala. And this time, what I'm going to do is calculate, rather than the sum, I'm going to do the mean relative abundance across all the cells in Guatemala. So I'm going to say function equals mean. Again, I want to remove those NA values. And I'm going to set ID equals false. This isn't really important, but it just removes an unnecessary additional column that the function will add by default. Okay. So let's take a look at what that is. So it's a bit of an odd format. It's sort of hard to interpret here, but what this is it's a data frame that has one row, because we had one polygon for Guatemala, and then 52 columns, one for each layer in the data set, one for each week of the year. If you had, someone I think earlier asked about, like, how could you do this for like all states at once? If you had an object, instead of having one polygon for Guatemala, had a whole bunch of polygons for different countries, this would give you, this data frame here would have multiple rows, one for each polygon in the input data set. So this is kind of a useless format for us, so I'm just going to transform it to be in a more standard format. So I'm going to say the weekly relative abundance, the weekly mean relative abundance. Oh, sorry. First, I want the first column of this data frame, I want to be the week of the year. So I'm going to extract that. Remember, the layer names of the raster data set are the weeks of the year. So I'm going to extract just that and convert it to a standard date format. And then for the second column, so one column for week, and then the second column will be the mean relative abundance in Guatemala. So I can convert that one row raster data frame to just a vector using as numeric. Okay, let's run that. And then let's take a look at that data set. So this is in a much nicer format. So you can see for each week of the year, it gives you the mean relative abundance. So this is a relative abundance metric, the mean across all the cells in Guatemala. It will include a whole bunch of cells that are zero because hooded warbler, I think, only occurs within like the kind of northeastern part of Guatemala, if I remember correctly. And finally, I have some ggplot code that will just plot this as a line and give it some nice labels and stuff. So hopefully you can see that. Right, so this is our migration chronology. Basically what it's saying is, there's this brief period in the breeding season from kind of May to August when they're just not in Guatemala at all. During that time, they're up in North America, up in the US mostly, where they breed. But then it looks like kind of
It looks like Matt froze. Sorry, we'll give him a minute here to restart. I mean, he was basically at the end. Fortunately, Matt basically got to the end of that chronology, which we'll also talk about next week. But we'll give Matt another minute or two. Lost power. Okay, so Matt's power went out in Seattle of all places. So I think maybe this is a good time to wrap up the webinar at this point. Scott, I think for Scott Walters, I think the best thing to do is to email Matt directly, and he will provide he will provide some direct assistance for you. Matt's going to be the best person to handle that specific R problem, not Andrew or I. Please follow up with the homework. Do we have a link for the homework, or was that it's in the R script? Yeah, it's in the bottom of the R script. So if you're coming next week, please go through the homework at the bottom of the R script, which we've provided a number of times here. We'll also try to send out the code for next week ahead of time. So unless there's any last urgence, I see Richard, if you need a certificate of attendance, please email one of us and we will make that happen. We've done it before, so we can give certificates of attendance. Okay. Access to the recording is there's a link up above. It'll be on this YouTube playlist in a few days.
Tom, before you close out, should we just put the link to the form there one more time?
The link to the
Google form.
yeah. All right, so just yeah, if you're still hanging on with us, before we shut it down, Andrew's going to post a link to the Google form that you can fill out for next week's material and provide some suggestions for content to work through. Okay. Great. Thank you, everyone. Have a good rest of your day or night wherever you are.
We'll see you next week.
Bye.